Yes, good morning, everybody. Well, in the introduction, we already got a brief description of today's program. So I think indeed we have an interesting selection of talks. The program is divided in two main parts. We'll start with a first session on innovations in water management, and we'll have a coffee break after that, followed by a second session which is on cost-effective urban water solutions. So in the interest of time, let me ask Dr. Royol Chitradon to give his talk. As already mentioned, he is Executive Director of the HAII Agro Informatics Institute in Bangkok, and it's a center of excellence. And the talk by Dr. Royol Chitradon will show us how to make results lasting.
Good morning, and I'd like to give you a talk about the Center of Excellence for Water Management in Thailand, how we develop that. In Thailand, His Majesty the King of Thailand, he spent almost 60 years to develop the water infrastructure. And before the year 1998, after he spent almost 60 years, the flood and drought was still there without management, the right management. So he started to think about how to integrate the information and making use of information. And since 1998, we start to develop that system to support the water resource management in Thailand. And we realized that this is the cheapest way to change the way that we manage water, and the quickest way. How we develop. The slide in front of you show that. So this is the basic concept that we are working on and the function we are about to serve. We need to setting up the system to serve the daily operation or in a normal situation, and also in the crisis situation. And the other things that we are lacking of in the past, the way that we develop the project, the information that we do have in the past, it's not enough to develop the right project or the right design for new infrastructure. With this information, we do hope that with the new system, it could help to change the way that we adapt, to do adaptation. You see that a Center of Excellence complies with the Hydroinformatics, that complies with the information database, and also with the information that we have, we try to do data processing or analysis for decision making, and also to serve the stakeholder in Thailand. We have the main agency that would operate water in Thailand. Altogether is 13, but with the supporting agency, altogether is 34 agencies. How we could integrate all of this one, and then to support the institutional, and also support capacity building at the micro level and at the national level, at the basin level and national level. The hydroinformatics itself, it will integrate the information and do a real-time monitoring, and also try to analyze the climate change adaptation that is addressed by World Bank and also Mr. Ambassador. All of this will serve all of this group of people who get involved in water resource management. Academic people, I don't do anything. Academic people, water agency, and water utility. You see that it's very important because when Mr. Ambassador mentioned that the water loss in Denmark is only less than 7%, but the water loss in Thailand is over 28%. We produce water and then 28% is leaking. We need that. We need the way that we manage water utility. And the citizen also to serve, and also for planning and development agency, for example, like to support our 4-year national plan, insurance and finance. You know that how much that we lost in the year 2011 is over 1.4, how can I say, trillion baht in Thailand. And a month ago, I joined the Insurance Association and start to analyze what happened in the year 2011. And the Insurance Association informed me that how much that they lost. It's 3.5 hundred-thousand. It's 350 billion baht. That's what they lost, billion baht. And NGO and also the regional body. And then I realized that with the climate change situation, with the problem that we start to have more because of the demand in Thailand is increasing, keep increasing, even our population is not increasing. It's almost zero in Thailand right now. It's going to be zero in the near future. But the demand is 35% increasing. How could we solve this? Demand management, because in the past, our concept is to focus on the supply management. We don't have any idea about the demand management. And also with the climate change, the dam or the reservoir that we built in the hill area in the upper north, the rainfall, it does not rain on the hill. It rains in the city because of the heat dome effect. It rains in the city, and we don't know how to keep water in the city. We still stick with the old concept. Put the water on the hill, and then release that to the farm area, and then the city. So we have to change the concept, but how we can do that and what we should do that. So we need hydroinformatics to change the way that we develop the infrastructure, to get the new concept, and also to change the way that we manage, because the seasonal change, the rainfall pattern change. So with this situation, and also the Center of Excellence on Water Management System that relies on the hydroinformatics itself, we need the international collaboration to understand the climate change, the new way to tackle the new problem, like the new concept for the city planning, how to make it absorb water. Exchange expertise, knowledge, information, and ideas from related agency and define principle and direction of the Center of Excellence. Because this will be last for over 100 years. We don't plan to do that for the next 5 years. But water is the issue that will be around us forever. This is what happened in Thailand in the year 2011. We had a big flood. Normally the annual average rainfall in Thailand is plus or minus 9%. But suddenly in the year 2011, the rainfall increased up to about 35% than average, over average. Suddenly, normally it's only plus or minus 9%. And then at that time, we did not realize that. You see, Thailand was hit by 5 tropical storms and also the other 3 monsoon throw. This is the average rainfall in Thailand. Normally it's only 1,324 millimeters. This is annual average rainfall. And suddenly in the year 2011, the average rainfall, annual average rainfall is up to 1,824 millimeters. That's what happened in Thailand. And at that time, we start to work with the HAII. It is over 5 years that we are partner and working together. And suddenly in the year 2015, we start to have a drought. Only 3 years or 4 years left. Then we start to have that. And then the annual average rainfall from above 35%, it's down to minus 15% suddenly. And then we don't have the water security system. How could we do that? Without the information, we could not do that. Without analysis, without modeling, we could not do that. After 18 years of working, we realized that what we do in the past, we try to integrate the information and analyze that and develop the decision support system, develop the system to support planning and understand climate change. That we hope that we could reach to water security. We realized that the system that we develop can be divided or structured into 3 main parts. The first part is pre-hydroinformatics, to integrate the information. And also the second part is investing in the know. The information that we integrate, we start to analyze and making use of that. What we can learn, what we know. And then post-hydroinformatics to improve water resource management. And we do hope that in the near future, we could reach to the point that we have water security system. But right now, we realize that we start to have food security system, water security system at the community level with the micromanagement that we support from the central information system. Pre-hydroinformatics itself is integrate data. So we start with a 5 or 6 main agency integrate the data. But we don't follow the theory in computer science. If we start with a theoretical work, we try to standardize, we try to do a software engineering, we could not come to this point. we start with our own way, integrate, replicate the data, and then reformat that and filtering that. After that, we integrate and copy it back to the agency. They can make use of information from their own agency, integrate with other agency. This is the way that we work. You see that we start from 1998, start with 4 PC linked together, create Linux cluster with a 2 terabyte of data set. But right now we have almost 300 terabyte of data, and it's going to be a 1 petabyte. And then we start to work with MIT, Massachusetts Institute, and also we work with a Japanese agency to adopt that technology in telemetering system. And right now it's our 4th generation of this one, telemetering system. We add some new. We're working with Siemens factory, we're working with Motorola factory to create a new modem that would serve, that would improve the telemetering system. And then to prove that our information is worth to develop, we start to setting up the site at the community level, at the micro level, to do their own water resource management. This is in rain-fed area. They manage their own. And then after the year 2011, before 2011, we start to work with DHI. Because of the information that we do have, we have to think about, analyze, and then develop the decision support system to support the water resource management at the national level. This is all the telemetering system that we're setting up. It's online, 850 stations. But in America, there are more than 8,000 online stations. But with the 850 stations, it's over the standard of UN. And during the flood in the year 2011, the technology that we developed was test. We operate UAV to monitor area, and also we operate this one. It's a boat that can get the profile of the canal, and it could save Bangkok at the time, the inner part of that, because we realized that which part of the canal that we need to do dredging. For example, like one canal in the east of Bangkok is over 15 to 20 kilometers. But we found that only 200 meters that we need to do a dredging. So we could do that in one day. And then the water moved past through. This is what we do. And also with a new technology, we are working with the IMU and also the new Ladybug camera. So we could get the 3D image. And also, we start to do this under Her Royal Highness Princess initiative. We have to understand the climate change, because in the past, when we are talking about the climate change, almost all the people talking about temperature increasing. No one talking about rain. But our king said that for a long, long time, that we need to do adaptation and understand the climate change. So we setting up the tower in the north of Bangkok. Is 117 meters high. So we could understand the pollution. We could understand the heat dome more and more, heat dome effect. It's about the same as in Taipei. The rainfall is 40% increasing not because of the water, not because of the climate, but because of the heat of the city itself. It's the same as what happened in Copenhagen, that you have a cloud burst problem. In Thailand also about the same. Just on Monday night, we had this problem again. Suddenly the rainfall in the north of Bangkok, and then flood happened. Integrate the information, setting up the monitoring system, and then analyze that. Hydroinformatics itself, we investing in the know, organizing the unorganized. And I realized that in developing country, when we try to tackle the problem, we try to organize the operator, the agency who operate water. But we don't organize the supporting agency. In America, you see that USGS, NOAA, NASA, they link together, they create the program. But in developing country, when we try to tackle the problem, we focus on the operator, not the supporting, because they see that it's supporting. But they don't understand that supporting can give you the understanding and a new way to solve the problem. With this information system that we are working with the HAII, so we could integrate the information and start with 13 agencies to be 34 agencies. So we create data center, supporting system, and then after we could integrate, we start to normalize the information, standardize that. Right now, it's about the time to standardize that. And then we provide the service through the website, through the application, mobile application, and also we do a modeling, and also the Internet TV, IP TV box that give us a simple solution to work with the local administration. For modeling, what we do, we start with the weather forecasting, weather research forecasting, and ocean model. We coupling that a part of the Earth system. And also, this can do 7-day rainfall forecasting, and it's an input of hydrological model that is divided into 3 parts. One is a water resource management model that we rely on the SWAN model. And the river model, we are working and running on a HAII 11, and flood model, we are running on a HAII 21. Then we could get, I do hope that in the near future, we would have the new system, is a water budgeting system. We could plan that how much water that we will have by next year and how we allocate that. This is this part. And then manage the river flow and start to optimize that. I will show some cases that the HAII working with us to do optimization in the northeast of Thailand. And when flood occur, we start to jump to this model, overland flow, 2D, because we have a large flood plain that cover over 90,000 square kilometers in the north, in the central part of Thailand. The largest model that we are running is daily running, operating. It's cover 150,000 square kilometers. And you see with the weather forecasting, we start to do a coupling model, a system model, and we can improve the accuracy quite a lot. And this is an example of daily precipitation forecast. We could, with the computing facility that we developed, we could do 3 by 3 square kilometers forecasting, the resolution that we could reach. And with the weather forecasting, and then input that to the water balance model. So we can do 1 week projection of each sub-basin. The red color is mean that we would have a drought problem in that sub-basin area. And the blue color, this is a good example. It's tend to be flood in this sub-basin area. And then we don't realize that because Gulf of Thailand is not, the depth is not that high. The depth is only 75 meters depth, Gulf of Thailand. And we did not have such problem in the past. But right now we start to have that. So we need a model to forecast such problem. A good example is in the year 2011, in October, suddenly surge happened, and we could drain flood from the north to the central part and to the Gulf of Thailand. Suddenly the surge come and increase the sea level up about 60 centimeters high. This is a decision support system that complies with all the model and link together to do the area management in each basin to support that how we allocate water, manage the water level, manage flood, manage drought. And these are all the computing facility that we developed at HAII since 1998, 1999. We started to have simple Linux cluster, but right now we are about to move to a part of that, like a data service. We start to move to a cloud service. It works quite well. It helps us a lot to speed up the service. And then the computing facility, we work together with DHI to speed up all the simulation by using the GPU, graphic processing unit, and also we try on the new Intel CPU, like a MIC that is massively parallel processing. The last part is post-hydroinformatics, provide the service. And right now, we have to submit a report, a short report to the Prime Minister. It has to be ready at 8 in the morning, and then show that to the Prime Minister by 8:30. Yes, we have to do that. We do this about a year, but we missed that for twice or 3 times. That we could not do that because sometimes our system is has some problem. But we learn how to make it stable, and we realized that we could not do by ourselves, so we separate the report into 9 reports and try to distribute our load to among the 34 agencies. They have to do, one is weather prediction report, the second one is irrigated, the report that the water situation in irrigated area, and also the report of the water situation in rain-fed area, and also the report of the water demand, and also 5 is water quality, and 6 is landslide, for example, flood, drought problem, and 7, we need water to serve the peak load. So 7 is very important because of the peak load cannot be rely on the gas turbine. If you have a problem with the peak load of the power demand in a certain peak, like in May, in a certain time, we need to start up the hydropower. It's much quicker. And 8 is economic and social. We realize that at the micro level, at the community level, that we do water resource management. Now they are not poor anymore. Their income is over 3 times increasing. Because in the past, what they can do only the rain season. During the dry season, they cannot do anything. They move to the city. Right now, they don't need that. They have water to do farming in dry season. And not only that, normally there is some lead time in the rainy season, about 1.5 months. And then they lost 40% of their product, farm product. And right now with the water security storage, secondary storage that we develop over there, then their income is 3 times increasing. That's what we learn. And we have to maintain the IT infrastructure to do all this one, the last part. So this is a flood monitoring system that we get, drought monitoring system, and right now it's support to the Prime Minister Operations Center. And this is Thai water. Sorry, these are in Thai, in Japanese, in English. But this is the mobile application is in Thai. Otherwise, you can try on that. You can download. It's on iOS, it's on Android system. So right now we do serve the water resource management in normal situation and in crisis situation. These are not that expensive. We develop all of this. In Thailand, we name that as a war room because we have to fight. And this is the mobile unit. During the time that we have the crisis, we can move all of the information to the certain area to support the management at the crisis area. These are about the community water resource management that right now we have over 603 villages that they could manage water by themselves. This is very important to show that if we could improve the normal operation, it means that we can reduce the flood and drought possibility. It's much cheaper to improve the normal operation than to solve the crisis. This is how we do the linear optimization. In the northeast of Thailand, complies with Ubolratana Reservoir, Lampao Reservoir, and Silinthorn Reservoir, altogether 3, and with 18 of year along Chi and Moon River. That is, we start to do a linear optimization. With this objective function, the optimization is the objective is do not exceed the dam safety level, mitigate downstream flooding, comply with the rule curves, and also avoid excessive spilling. This is all this one. And you see the modeling is in this part is MAI 11, and then with the output of the hydrological model, then we input this objective function that rely on the linear optimization, linear programming. That is an inequality equation. And then optimization, and we do something like a reanalysis to prove that it works. You see, if we don't do anything, this is what we have in the year 2006. So we lose over is a lot. The water that we drain it without any, we lose that. And if we do optimization, we could reach to the blue line. So we have more water for the dry season. This is all the algorithm that they do. Yes, one is a hydrological model for the Northeast, cover Chi and Moon, two main rivers, and also the operation of the reservoir is a Ubolratana model, and then do optimization based on the inequality equation. This is all that we learned after 18 years of development.